Hey guys, my name is Tom, and in this video I will give you an introduction to finding tensions in ropes. Okay, so all within the context of some basic physics. Let's take a look at what we have. Well, first of all, see, smiling. You've got to be smiling. Okay. Imagine the following scenario. You have a ceiling. So here's a ceiling. Okay. Move this a little. Okay, that's our ceiling. Now imagine you suspend a weight from the ceiling that looks like this. Maybe it's some box, who knows? There we are. And of course, what we want to find is the tension in the rope. So to find the tension in the rope, we need to write down two basic facts. The object is not accelerating vertically, nor is it accelerating horizontally, which means you can write the following. The sum of the forces in the y direction has to be 0, and the sum of the forces in the x direction also has to be 0. And here keep in mind that we're setting up our coordinate system so that it looks like this. I'm drawing it on the side. This is your x and this is your y. Okay? So, no forces are acting in the horizontal direction. So that's 0. That is taken care of. In the y direction, however, what you have is this. You've got the tension in the rope, okay, which is a vector that points this way. And this is opposed by the weight of the object, which is, say, this orange quantity. And because the object is not accelerating vertically, these are equal. Okay, so in other words, when you draw your vectors, you want to draw them so that they are equal in length. They point in opposite directions, but they are equal in length, as I've shown you here. Okay, of course, it doesn't have to be perfect, but suggestive more or less of the physical situation. And now mathematically what we will do is this. We will take the tension, which we conveniently enough represent using the letter T. And to it we will add the weight. Okay. Or subtract the weight. And this whole equation has to be equal to 0. Okay? So the sum of the forces in the y direction is 0. The object is not accelerating vertically. It's just hanging there from the ceiling as you see in the picture. So what this tells us immediately is the following. That you add w to both sides, and you sum these. Oh, that's not a pretty line. Okay. There we go, okay? And you add them, so you find that T equals W, like this. So the tension in the rope, represented using the letter T, is equal to W, which is represented here, right? Like this. Those two are equal. Because they are equal, we can say that the object is not accelerating vertically, so the sum of the forces in the y direction is 0. And that is it. Okay? So say specifically you are told now that, this object here is 50. Then what you can write down immediately is that the tension in the rope is equal to 50 pounds. Okay? Like that. Or, of course, if this is in newtons, as might be the case, depending on how you're working the units, okay, then you might be told that this is 50 newtons, and then the tension would be written as T equals 50 N for newtons. There we are. So that's the basic setup for this kind of exercise. The tension is balanced by the weight, or the weight is balanced by the tension, whichever one, however you want to think about it. The sum of the forces in the x direction is 0. Sum of the forces in the y direction is also 0. The object is not accelerating vertically. It's not moving up or down. It's just limply hanging in place, making the rope, I'm sure, taut. That means you write this basic equation that the tension minus the weight is 0. Move the w to the right side, so it tells us that the tension equals the weight. If we're talking about pounds, it could be something like T equals 50 pounds. If we're talking about newtons, as is common now, of course, in sciences, nobody uses pounds anymore, really. Then you're talking about 50 newtons as the tension in the rope. And that's it. So thank you for watching. Have a great day.